In this video, we're going to look at simple quadratic sequences. What are quadratic sequences and how we can find the general term for a simple quadratic sequence. So a quadratic sequence is one that has an n squared in the general term. For example, if we had un equals n squared plus 3n minus 4, or another example might be un equals 3n squared minus 7n plus 15. And any one of these with an n squared in the general term is a quadratic sequence. So let's have a look at a couple of quadratic sequences. Now here we don't know the general term, but we've got two sequences, and there's one thing we need to notice with these. If we do like we did for a linear sequence and try to find the difference, we notice that each time the difference is different. But what is important is that if we then find the differences of the differences, sometimes called the second difference, then these are all the same. And that is true for any quadratic sequence. So if we have a sequence of numbers where the first differences are different but the second differences are the same, then we know we're dealing with a quadratic sequence. With this second one, it starts off with 6, then 10, then 14, then 18, and then 22. And once again that gives us second differences, which are this time always 4, but the important thing is all the second differences are the same. So both of these are quadratic sequences. For some quadratic sequences, these two for example, we can compare them to the simplest quadratic sequence there is. And the simplest quadratic sequence there is the square numbers 1, 4, 9, 16, 25 and 36. And that has general term n squared because it is just the square numbers. So if we now compare this to the first of those two sequences, which was 0, 3, 8, 15, 24 and 35, we can see a relationship between each pair of numbers in these two sequences. Each of the ones in the green sequence is one less than the corresponding term in the n squared in the red sequence. So for this one, un is equal to n squared minus 1. Our second sequence that we were looking at was 2, 8, 18, 32, 50 and 72, and once again looking at the pairs of corresponding values in these two sequences, we can once again see a relationship. This time the green one is double the corresponding red number, so this time we have un equals 2 times n squared. This method works for simple quadratic sequences that we can relate easily to the square numbers. And in a future video we shall be looking at how we can use a method to find the general term for any quadratic sequence that does not necessarily look as similar to the square numbers as the ones we have seen in this video.